What if the next giant leap for humanity wasn't just about reaching space, but about redefining how we inhabit it? Think about it. A space station that doesn't need astronauts to maintain it, one that can repair itself, adapt to challenges, and even expand its own infrastructure, all powered by artificial intelligence. This isn't a distant dream or a scene from a sci-fi movie. It's a vision that's rapidly taking shape thanks to the incredible strides we're making in AI and robotics. But here's the real question: could AI actually design, build, and operate the first fully autonomous space station? The answer might surprise you. In this video, we'll break down the cutting-edge technologies that could make this possible, uncover the challenges standing in the way, and explore what it could mean for the future of space exploration and humanity itself. Get ready to see space stations in a whole new light. Let's dive in. Picture this: a space station floating silently in the void, humming with life, not because of astronauts bustling inside, but because it's alive in its own way. A fully autonomous space station isn't just a collection of metal and wires. It's a self-sustaining ecosystem designed to think, adapt, and thrive without constant human oversight. Unlike the International Space Station, which relies heavily on ground control and frequent resupply missions, this next-generation habitat would manage its own resources, repair its own systems, and even conduct scientific experiments, all while orbiting Earth or venturing deeper into space. To understand how groundbreaking this vision is, let's take a step back. The International Space Station, or ISS, has been humanity's outpost in orbit for over 2 decades. It's a marvel of engineering, sure, but it's also a reminder of how much we rely on human labor and Earth-based support. Every bolt tightened, every experiment monitored, every supply shipment scheduled. It's a constant dance between humans on the ground and astronauts in space. Now imagine a future where AI takes the lead. Picture a station that can diagnose a malfunctioning module, deploy a robotic arm to fix it, and recalibrate its systems, all in real time without a single human command. This isn't just science fiction. In fact, the seeds of this idea have been planted for decades. Visionaries like Gerard O'Neill dreamed of massive space habitats, known as O'Neill cylinders, that could house thousands of people. These self-contained worlds would generate their own gravity, grow their own food, and recycle every drop of water. While O'Neill's designs were focused on human habitation, the principles behind them, self-sufficiency, resource management, and adaptability, are exactly what an autonomous space station would need to embody. Now, here's where AI comes in. Artificial intelligence could transform these ambitious concepts into reality. Instead of relying on pre-programmed instructions, an AI-driven station would learn from its environment, predict potential issues before they arise, and make decisions on the fly. It could optimize energy use, manage life support systems, and even prioritize scientific research based on real-time data. The result: a space station that's not just a tool for exploration, but a partner in discovery. So, what would it take to make this vision a reality? What technologies would need to come together to create a station that's truly autonomous? Let's dive into the key innovations that could turn this dream into our next giant leap. Space exploration has always been a proving ground for cutting-edge technology, and artificial intelligence has been quietly shaping its progress for decades. Think back to the 1970s, when robotic probes like Voyager 1 and 2 were sent on their epic journeys across the solar system. These early missions relied on pre-programmed instructions with little room for adaptation. But even then, the seeds of AI were being planted: systems that could autonomously adjust their trajectories, manage power usage, and make basic decisions to ensure mission success. Fast forward to the Mars rovers like Spirit, Opportunity, and the more recent Perseverance, and you'll see how far we've come. These rovers aren't just following orders, they're analyzing terrain, selecting targets for study, and even deciding the safest paths to take, all in real time, millions of miles from Earth. AI has become indispensable in space exploration, not just for navigation but for sifting through mountains of data. Imagine the sheer volume of information sent back by a rover or a probe: images, atmospheric readings, geological samples. Without AI, scientists would be overwhelmed, but with it, we can identify patterns, spot anomalies, and even predict potential hazards before they become problems. Decision-making, too, has shifted from ground control to the machines themselves. When communication delays make real-time control impossible, like on Mars, where signals can take up to 20 minutes to reach Earth, AI steps in to keep missions moving forward. But for all its achievements, AI in space isn't without its limits. Current systems excel in specific, well-defined tasks, but they struggle with the unpredictable and the unknown. They lack the ability to truly learn on the fly or adapt to entirely new challenges without human intervention, and that's where the next frontier lies. If we're talking about building and maintaining a fully autonomous space station, we're talking about a system that can handle not just navigation or data analysis, but also repair modules, manage life support, and even troubleshoot unexpected failures, all without waiting for instructions from Earth. So, how do we get there? How can AI evolve to meet these monumental challenges? When it comes to designing something as complex and mission-critical as a fully autonomous space station, every detail matters. And this is where artificial intelligence steps in, not just as a tool, but as a game-changing partner in the design and engineering process. Imagine a system that doesn't just follow human instructions, but actively contributes ideas, testing thousands of possibilities in seconds. This is the promise of AI-driven design, a blueprint for autonomy that could redefine how we build for space. At the heart of this revolution are generative design algorithms. These aren't your typical design tools. Instead of engineers manually sketching and tweaking blueprints, AI can take a set of parameters like weight limits, material strength, and energy efficiency, and generate hundreds, even thousands of potential designs. Each one is optimized for the unique challenges of space, from enduring extreme temperatures to resisting micrometeoroid impacts. For example, NASA has already used AI to create spacecraft components that are lighter, stronger, and more efficient than anything a human designer could have imagined. One standout example is the spacecraft chassis designed by AI, which reduced weight by over 30% while maintaining structural integrity. That kind of innovation isn't just impressive, it's essential for missions where every gram counts. But AI doesn't stop at creating designs. It also simulates how those designs will perform in the unforgiving environment of space. Think of it as a virtual testing ground where AI can run countless scenarios, everything from solar radiation exposure to sudden pressure changes, and predict how the station will hold up. This means engineers can identify potential weaknesses long before construction begins, saving time, resources, and potentially lives. It's like having a crystal ball for space engineering, offering insights that were once impossible to achieve. Of course, turning these AI-generated designs into reality isn't without its challenges. While the algorithms can create structures that push the boundaries of what's possible, actually building them requires precision engineering and materials that may not yet exist. Questions arise: can we manufacture these intricate designs with current technology? How do we ensure that the AI's creations are not just theoretically sound but practically feasible? These are the hurdles that engineers and scientists will need to overcome as they bridge the gap between digital innovation and physical construction. So, as we marvel at the potential of AI-driven design, it's worth asking, what's next? How do we take these groundbreaking ideas and turn them into a tangible, functional space station? And what new frontiers will this collaboration between human ingenuity and artificial intelligence open up? The answers to these questions could shape the future of space exploration and redefine what it means to build for the stars. Building a space station in the vacuum of space is no small feat, especially when you consider the unique challenges of zero gravity. Imagine trying to assemble a massive structure without the luxury of a stable foundation or the ability to simply bolt things together. This is where robotics steps in as the ultimate problem solver. Autonomous robots equipped with advanced AI could tackle the complexities of construction in an environment where humans would struggle to even hold a wrench steady. One of the biggest hurdles is precision. In zero gravity, even the smallest miscalculation can send components drifting off into the void. Robotic arms, like those used in the Robonaut project, are designed to perform delicate tasks with incredible accuracy. These machines can weld, fasten, and position materials with a level of precision that far exceeds human capability in such conditions. But it's not just about steady hands. Robots also need to adapt to unexpected challenges, like shifting materials or sudden changes in the station's orientation. That's where AI comes in, constantly analyzing data and making split-second adjustments to keep everything on track. Another game changer is 3D printing in space. Instead of launching every single part from Earth, robots could manufacture components on site, using materials found in space or brought along in compact forms. This not only reduces the cost and complexity of missions, but also allows for on-the-fly repairs and modifications. Picture a robotic arm extruding molten metal to create a custom bracket or even an entire module, layer by layer, in the vacuum of space. It's like having a construction crew and a factory all rolled into one, operating autonomously millions of miles from Earth. Then there's the concept of swarm robotics, teams of smaller robots working together like a colony of ants. Instead of relying on a single, large machine, these swarms could divide tasks among themselves, assembling sections of the station simultaneously. One group might handle welding, while another focuses on transporting materials or inspecting completed work. The coordination required for this level of teamwork is staggering, but AI could act as the conductor, ensuring every robot knows its role and works in harmony with the others. So, how can AI ensure these robots work seamlessly together? The answer lies in advanced algorithms that enable real-time communication and decision-making. Each robot would be equipped with sensors and cameras, feeding data back to a central AI system that monitors progress and adjusts plans as needed. If one robot encounters a problem, the AI could instantly reroute tasks to others, keeping the project on schedule. It's a symphony of technology, with AI as the maestro, ensuring every note is played perfectly. The potential here is immense. With robotics and AI working hand in hand, the dream of building a fully autonomous space station could become a reality sooner than we think. But as we push the boundaries of what's possible, one question remains. How do we ensure these systems are not only efficient but also resilient enough to handle the unpredictable nature of space? Picture a space station orbiting Earth, completely self-sufficient and humming with activity. But here's the twist: there's no human crew managing the day-to-day operations. Instead, an artificial intelligence system is at the helm, overseeing every critical resource to keep the station running smoothly. From oxygen and water to energy and waste, AI could become the ultimate steward of a fully autonomous space station. But how would it manage these resources so seamlessly? Let's break it down. One of the most critical tasks for an AI steward would be managing closed-loop life support systems, essentially systems that recycle and reuse resources like air, water, and even waste. Think of it as a high-tech version of nature's own cycles. For example, AI could monitor oxygen levels in real time, adjusting air filtration systems to maintain the perfect balance. It could also oversee water purification, ensuring every drop is recycled efficiently, from drinking water to the condensation produced by human breath. The key here is optimization. AI wouldn't just maintain these systems, it would constantly analyze data to make them more efficient, squeezing every ounce of utility from limited resources. But it doesn't stop there. Energy management would be another cornerstone of AI's role. Solar panels, nuclear reactors, or other power sources would need to be carefully monitored and allocated. An AI system could predict energy needs based on the station's activities, rerouting power to critical systems during emergencies or conserving energy during periods of low usage. And when it comes to waste, AI could oversee advanced recycling systems, breaking down materials into their base components to be reused for repairs, manufacturing, or even food production. Speaking of food, AI-driven hydroponics could revolutionize how space stations sustain life. Imagine rows of plants growing in nutrient-rich solutions, all monitored and adjusted by AI to maximize yield. The system could regulate light, temperature, and nutrient levels to ensure crops grow efficiently, providing fresh produce for the station's inhabitants, whether they're humans or other AI systems designed for maintenance tasks. This kind of technology isn't just futuristic, it's already being tested in Earth-based experiments, proving its potential for space. Of course, no system is perfect. Even the most advanced AI would need to plan for the unexpected. That's where predictive maintenance comes in. By constantly analyzing data from sensors and equipment, AI could detect potential failures before they happen. A malfunctioning oxygen generator or a leak in the water system could be identified and repaired autonomously, preventing catastrophic system failures. This ability to anticipate problems and act proactively would be essential for long-term survival in the harsh environment of space. But here's the big question: what happens when resources run low or systems fail despite all these safeguards? Could an AI adapt in real time, finding creative solutions to keep the station operational? Or would it rely on pre-programmed protocols, potentially leaving it vulnerable to unforeseen challenges? These are the kinds of questions that make the idea of an AI-managed space station both thrilling and complex. Imagine a space station orbiting Earth, constantly exposed to the harsh realities of space: micrometeoroids zipping by at incredible speeds, solar radiation bombarding its surface, and the inevitable wear and tear of operating in such an unforgiving environment. Now picture this same station equipped with self-healing systems, overseen by artificial intelligence, capable of detecting and repairing damage in real time. This isn't science fiction, it's a vision of what AI could bring to the future of space exploration. One of the most groundbreaking innovations in this area is the development of self-healing materials. Think of polymers that can seal themselves when punctured, much like how human skin heals after a cut. These materials could be integrated into the station's walls, shielding it from micrometeoroid impact. But here's where AI steps in. It wouldn't just rely on passive healing. Instead, it would actively monitor the station's structural integrity, using sensors to detect even the smallest cracks or breaches. When damage is detected, AI could deploy autonomous repair drones to patch the area, ensuring the station remains airtight and functional. But what about more complex damage, say, a critical system failure caused by radiation? AI's ability to prioritize repairs becomes crucial here. It wouldn't just fix the first problem it encounters, it would assess the severity of each issue, allocate resources efficiently, and even predict potential future failures based on patterns of wear and stress. This proactive approach could mean the difference between a minor repair and a catastrophic failure. Now, let's take it a step further. Space is unpredictable and emergencies can arise without warning. How would AI handle a sudden, unexpected crisis, like a large debris collision or a sudden spike in radiation levels? The answer lies in its ability to adapt. AI systems could continuously learn from past incidents, refining their response strategies to become faster and more effective over time. They could even simulate potential scenarios in real time, preparing the station for the worst while keeping it operational. The integration of self-healing systems and AI-driven maintenance isn't just about keeping the station alive. It's about creating a resilient, self-sustaining habitat that can thrive in the most extreme conditions. And as we push further into the cosmos, these technologies could become the backbone of humanity's presence in space. So, what happens when the unexpected strikes? That's when AI truly shines, turning potential disasters into manageable challenges and ensuring the station and its crew can keep reaching for the stars. But even in a world where AI becomes the backbone of a space station, humans still play an irreplaceable role. Think about it. While AI can handle repetitive tasks, monitor systems, and even predict potential failures, there's something uniquely human about creativity, adaptability, and intuition. Astronauts bring the ability to make split-second decisions in unpredictable situations, solve problems that fall outside the scope of programmed algorithms, and bring a level of ingenuity that machines simply can't replicate. Imagine a scenario where the station's AI detects an anomaly in the life support system. It can analyze the data, flag the issue, and even suggest solutions. But when it comes to implementing a fix in a high-pressure, high-stakes environment, that's where human expertise shines. Astronauts can assess the situation, weigh the risks, and apply their hands-on experience to ensure the station stays operational. It's a partnership, AI as the tireless, data-driven assistant, and humans as the ultimate decision-makers. This collaboration also hinges on trust. For astronauts to rely on AI, they need to know the system is not only accurate but also transparent. If an AI recommends a course of action, astronauts must understand why. Clear communication between humans and machines becomes critical, especially when lives are on the line. This trust isn't built overnight. It's the result of rigorous testing, real-world applications, and a deep understanding of how AI operates. But as we lean more heavily on AI in such critical roles, new ethical questions emerge. What happens if an AI makes a mistake? Who is accountable when decisions are made by algorithms? And how do we ensure that AI systems prioritize human safety above all else? These are the kinds of challenges we'll need to address as we move toward a future where humans and AI work side by side in the unforgiving environment of space. The balance between autonomy and human oversight isn't just a technical challenge, it's a deeply human one. As we marvel at the possibilities of AI-driven space exploration, it's impossible to ignore the ethical dilemmas that come with it. Can we truly trust artificial intelligence with the future of humanity in the vast, unforgiving expanse of space? This isn't just a question of technology. It's a question of morality, responsibility, and the very essence of what it means to explore. One of the biggest concerns is bias in AI decision-making. Even the most advanced algorithms are only as good as the data they're trained on. If that data contains biases, whether intentional or not, those biases can influence critical decisions in space. Imagine an AI tasked with managing life support systems or allocating resources on a space station. If its programming favors certain outcomes over others, the consequences could be catastrophic. This isn't just hypothetical. We've already seen examples of biased AI in fields like healthcare and criminal justice. In space where the stakes are exponentially higher, the margin for error shrinks to almost zero. Then there's the risk of malfunction. Space is an incredibly harsh environment, full of radiation, extreme temperatures, and unpredictable conditions. Even the most rigorously tested AI systems could encounter scenarios they weren't programmed to handle. What happens if an AI controlling a space station's navigation system fails during a critical maneuver? Or if it misinterprets a sensor reading, leading to a catastrophic error? These aren't just technical problems, they're ethical ones. When lives are on the line, who bears the responsibility for those mistakes? The engineers who designed the AI, the scientists who deployed it, or the AI itself? This brings us to the heart of the matter, the moral responsibility of delegating life and death decisions to machines. AI doesn't have emotions, ethics, or a sense of morality. It operates purely on logic and data. But space exploration often requires more than just logical decisions. It requires empathy, intuition, and the ability to weigh complex ethical considerations. Can we really entrust machines with decisions that could determine the fate of astronauts or even entire missions? And if something goes wrong, how do we hold an algorithm accountable? To navigate these challenges, we need robust ethical frameworks specifically designed for AI in space. These frameworks must address not only the technical aspects of AI development, but also the philosophical and moral questions they raise. How do we ensure AI remains aligned with human values? How do we balance the efficiency of automation with the irreplaceable judgment of human beings? And perhaps most importantly, how do we prevent the misuse of AI in ways that could harm not just individuals, but the future of space exploration itself? These questions don't have easy answers, but they're essential to address as we move forward. After all, the decisions we make today will shape the trajectory of humanity's journey into the stars and the role AI plays in that journey. As we venture further into the realm of AI-driven space exploration, one critical question emerges: who's responsible when things go wrong? Imagine an autonomous space station makes a critical error, damaging a satellite or even endangering human life. Who takes the blame? The AI developers, the company operating the station, or the international organizations overseeing its deployment? This is just one of the many legal challenges that come with deploying artificial intelligence in space, a frontier where laws are still catching up to technology. Intellectual property is another tangled issue. If an AI designs a groundbreaking space station component, who owns the rights to that innovation? Is it the company that programmed the AI, the organization that funded its development, or the AI itself? Current laws aren't equipped to handle these questions, and as AI becomes more autonomous, the lines of ownership will only blur further. This isn't just about patents, it's about ensuring that innovation is rewarded while fostering collaboration in a field that benefits humanity as a whole. And then there's the matter of international cooperation. Space is governed by treaties like the Outer Space Treaty of 1967, which was written long before AI was a factor. These agreements were designed to prevent conflicts and ensure that space remains a peaceful domain. But as AI takes on more responsibilities, from managing space stations to making split-second decisions, these treaties will need to evolve. How do we regulate systems that can learn and adapt independently? What happens when two nations disagree on the ethical boundaries of AI in space? The role of governments and private companies will be pivotal in shaping this new legal landscape. Governments will need to create frameworks that balance innovation with accountability, while private companies must navigate these regulations without stifling progress. It's a delicate dance, but one that will define the future of space exploration. So, as we look to the stars, we must also look to the laws that will guide us, ensuring that the final frontier remains a place of discovery, not dispute. The economics of building an autonomous space station powered by AI is a topic that sparks as much debate as it does curiosity. Let's break it down. What would it actually cost to create something like this, and could the benefits outweigh the price tag? Developing and deploying advanced AI and robotics systems for space isn't cheap. We're talking about cutting-edge technology that requires years of research, testing, and refinement. The hardware alone, sophisticated sensors, durable robotic arms, and self-repairing materials, could run into the billions, and that's before factoring in the cost of launching it all into orbit. But here's where it gets interesting. While the upfront costs are undeniably steep, the long-term benefits could be transformative. Imagine a space station capable of conducting experiments without human intervention, gathering data around the clock, and even repairing itself in the harsh environment of space. The scientific discoveries alone could revolutionize our understanding of everything from zero-gravity manufacturing to the origins of the universe. And then there's the commercial potential. Companies could use these stations to test new technologies, manufacture unique materials, or even offer space tourism experiences, all without the risks and costs associated with sending humans into orbit. Speaking of risk, that's another huge factor. By removing humans from the equation, we eliminate the dangers of space travel, which not only saves lives but also reduces the need for life support systems and other human-centric infrastructure. This could bring costs down significantly over time, but here's the big question: who's going to foot the bill? Governments, private companies, or a combination of both? Historically, space exploration has been driven by national agencies, but in recent years, private enterprises have stepped up in a big way. Companies like SpaceX and Blue Origin have shown that commercial space ventures can be both profitable and groundbreaking. Could they lead the charge in funding autonomous space stations, or will it take a global coalition of nations pooling resources to make it happen? The answer likely lies somewhere in the middle. A collaborative effort between public and private sectors could spread the financial burden while maximizing the benefits for everyone involved. After all, the potential rewards, scientific breakthroughs, economic opportunities, and a safer way to explore the cosmos are too significant to ignore. So, is it worth the investment? When you weigh the costs against the possibilities, the answer might just be a resounding yes. Imagine a space station orbiting Earth, not just as a hub for human astronauts, but as a fully autonomous laboratory where artificial intelligence tirelessly sifts through the mysteries of the cosmos. This isn't science fiction, it's a future that's closer than you might think. An autonomous space station powered by advanced AI could revolutionize how we conduct scientific research in space, unlocking secrets of the universe that have eluded us for centuries. At the heart of this revolution is AI's unparalleled ability to process and analyze data. Think about the sheer volume of information generated by telescopes scanning distant galaxies, particle detectors hunting for elusive subatomic particles, or biological experiments studying how life adapts to microgravity. Human scientists, no matter how brilliant, are limited by time and capacity. But AI, it can work around the clock, sifting through petabytes of data in seconds, identifying patterns and anomalies that might otherwise go unnoticed. For example, AI algorithms could comb through telescope data to detect faint signals from exoplanets or even identify potential signs of extraterrestrial life. Or, in the realm of particle physics, AI could analyze collisions in particle detectors to uncover new fundamental forces or particles that challenge our understanding of the universe. But the real game changer is AI's potential to make discoveries independently. Unlike traditional research methods where humans design experiments and interpret results, AI systems could take the lead. They could propose new hypotheses, design experiments to test them, and refine their understanding based on the outcomes, all without direct human intervention. This level of autonomy could accelerate scientific breakthroughs exponentially. Imagine an AI discovering a new type of cosmic phenomenon or unraveling the mysteries of dark matter entirely on its own. The possibilities are as vast as the universe itself, And it's not just about what AI can do, it's about what it enables us to do. By delegating routine data analysis and experimentation to AI, human scientists can focus on the bigger picture, interpreting discoveries, developing new theories, and exploring the implications of what we find. This collaborative dynamic between humans and machines could push the boundaries of knowledge further than ever before. So, what new frontiers could this open for humanity? An autonomous space station could help us answer some of the most profound questions we've ever asked. Are we alone in the universe? What is the true nature of dark energy? How did life begin, and could it exist elsewhere? These are questions that have fascinated us for generations, and with AI as our partner, we might finally be on the verge of finding answers. The stars may no longer feel so distant, and the universe may no longer seem so unknowable. The future of scientific discovery is bright, and AI is lighting the way. Space tourism has long been the stuff of dreams, reserved for the ultra-wealthy or the exceptionally lucky. But what if AI could change that? Imagine a future where space stations, powered by advanced artificial intelligence, become bustling hubs for tourists from all walks of life. These stations wouldn't just be places to visit, they'd be fully autonomous ecosystems designed to make the experience safe, comfortable, and unforgettable. Picture this: you step aboard a space station, and from the moment you arrive, an AI system tailors your environment to your needs. The life support systems adjust to your preferences, ensuring the air temperature, humidity, and lighting are just right. Even your meals are customized, prepared by robotic chefs that know your dietary requirements better than you do. And if you're feeling adventurous, you can strap on a VR headset and take a guided tour of distant galaxies, all without leaving the station's safety. But it's not just about comfort. AI plays a critical role in keeping space tourists safe. Advanced algorithms monitor every system on the station, predicting and preventing potential failures before they happen. If an emergency does arise, AI can instantly coordinate evacuation routes, manage life support, and even guide passengers to safety with real-time instructions. It's like having a team of experts watching over you at all times, ensuring your journey is as secure as it is thrilling. The impact of this goes far beyond individual experiences. Making space accessible to more people could transform our economy and culture. Space tourism could become a multi-billion-dollar industry, creating jobs and driving innovation in ways we can't yet imagine. It could also inspire a new generation of explorers, artists, and thinkers, as more people gain the opportunity to see Earth from above and experience the awe of the cosmos firsthand. But with this exciting potential comes an important question. How do we make sure this new era of exploration is sustainable? Space is a fragile environment, and the last thing we want is to bring the same challenges we face on Earth, like pollution and overuse, into the stars. AI could be part of the solution, helping us design stations that minimize waste, recycle resources, and operate with near-zero environmental impact. So, as we stand on the brink of this new frontier, the possibilities are endless, but the responsibility is equally immense. How do we balance the thrill of discovery with the need to protect the very environment we're exploring? It's a question that will shape the future of space tourism and the role AI plays in it. Picture this: a massive asteroid hurtling toward Earth, undetected until it's almost too late. It sounds like the plot of a Hollywood blockbuster, but the threat of near-Earth objects is very real, and it's one of the reasons why an autonomous space station powered by artificial intelligence could be a game-changer for planetary defense. By leveraging AI's ability to process vast amounts of data at lightning speed, such a station could serve as humanity's first line of defense against cosmic threats, acting as a sentinel in the void of space. One of the most critical roles an AI-driven space station could play is in the detection and tracking of near-Earth objects. Traditional telescopes and ground-based systems have their limits, but a space-based observatory equipped with advanced AI algorithms could continuously scan the skies, identifying potential hazards like asteroids or comets long before they pose a danger. These systems wouldn't just spot objects, they'd analyze their trajectories, predict potential impacts, and even assess the likelihood of collision with incredible precision. This early warning capability could buy us precious time to prepare and respond, turning what might have been a catastrophic event into a manageable challenge. But detection is only half the battle. Once a threat is identified, the real work begins. AI could play a pivotal role in coordinating deflection missions, whether by calculating the optimal angle for a kinetic impactor or designing the flight path of a spacecraft tasked with nudging an asteroid off course. The autonomous nature of the station would allow it to make split-second decisions, adjusting strategies in real time based on new data. Imagine a scenario where a fleet of small, AI-guided spacecraft is deployed to intercept an incoming object, each one working in perfect harmony to alter its trajectory. It's a level of coordination that would be nearly impossible for human operators alone, especially under the pressure of an impending threat. Of course, planetary defense isn't just about technology, it's also about collaboration. An AI space station could serve as a hub for international cooperation, sharing data and resources with countries around the world. Early warning systems would be most effective if they're globally accessible, ensuring that no nation is left in the dark. By fostering a spirit of unity, AI could help humanity face these threats as one, rather than fragmented and unprepared. Now, while protecting Earth from space threats is a critical mission, it's just one example of how AI could tackle global challenges from orbit. From monitoring climate change to managing space debris, the possibilities are as vast as the cosmos itself. So, as we look to the stars, one question remains: what other pressing issues could AI help us solve from its vantage point high above our planet? The answers might just redefine how we think about technology, collaboration, and our place in the universe. Imagine trying to hold a conversation with someone on the other side of the planet, but with a delay so long that every word takes minutes to reach them. Now picture that same challenge, but multiplied by the vast distances of space. This is the reality of communication between Earth and a fully autonomous space station. One of the most critical roles AI could play in such a mission is managing this communication and ensuring that data, commands, and even human interactions flow smoothly across the void. The first hurdle is latency. In space, signals traveling at the speed of light can still take anywhere from a few seconds to several minutes to reach their destination, depending on how far the station is from Earth. For routine operations, this delay might be manageable, but in emergencies, every second counts. AI could step in to prioritize critical communications, instantly flagging urgent messages and routing them through the fastest available channels. Think of it as a cosmic traffic controller, ensuring that the most important information gets through without delay. Bandwidth is another challenge. Spacecraft have limited power and storage, and transmitting vast amounts of data across millions of miles isn't easy. This is where AI-driven innovations like data compression and error correction come into play. By analyzing patterns in the data, AI could shrink files without losing essential information, making transmissions faster and more efficient. And if any data gets corrupted during the journey, say, due to solar radiation, AI algorithms could detect and fix errors in real time, ensuring that nothing gets lost in translation. But what happens when communication breaks down entirely? AI could act as a failsafe, stepping in to make autonomous decisions when contact with Earth is lost. For example, if a critical system on the space station malfunctions and Earth can't respond in time, AI could analyze the situation, weigh the risks, and execute a solution, all without human intervention. It's like having a highly skilled pilot on board who never sleeps and never gets overwhelmed by the complexity of the task. So, how can AI ensure seamless communication, especially in emergencies? By combining speed, efficiency, and adaptability, it could bridge the gap between Earth and space like never before. But as we push the boundaries of what's possible, one question remains. How do we ensure that this technology is reliable enough to handle the unpredictable challenges of deep space? Powering a fully autonomous space station is no small feat, especially when you consider the delicate balance between energy supply and demand in the harsh environment of space. This is where artificial intelligence steps in, not just as a tool, but as a critical system manager. Picture this, a sprawling station orbiting Earth, equipped with solar panels glinting in the sunlight, compact nuclear reactors humming quietly in the background, and advanced energy storage systems ready to kick in when needed. AI becomes the brains behind it all, constantly monitoring, adjusting, and predicting. Solar panels are a natural choice for space stations, given the abundance of sunlight beyond Earth's atmosphere. But the challenge lies in their efficiency. AI can optimize the angle and positioning of these panels in real time, ensuring they capture the maximum amount of solar energy. And when the station passes into Earth's shadow, where sunlight is temporarily blocked, AI seamlessly transitions to stored energy or other power sources like compact nuclear reactors. These reactors, while small, can provide a steady and reliable energy supply, and AI ensures they operate safely and efficiently, adjusting output based on the station's needs. Energy storage is another critical piece of the puzzle. Advanced batteries or other storage solutions must be carefully managed to avoid overcharging or depletion. AI excels here too, predicting usage patterns and ensuring energy reserves are always ready for peak demand. It's like having a meticulous energy accountant working around the clock, balancing the books so the station never runs out of power. But what happens when things go wrong? Space is unpredictable, and energy sources can face disruptions, whether from solar flares, equipment malfunctions, or other unforeseen events. This is where AI's predictive capabilities truly shine. By analyzing vast amounts of data, AI can foresee potential energy shortages and take proactive steps to mitigate them, rerouting power or activating backup systems before a crisis occurs. It's not just about reacting, it's about staying one step ahead. So, what does all this mean for the future of space exploration? An AI-managed energy system doesn't just keep the lights on. It ensures the station can operate efficiently, sustainably, and with minimal human intervention. But the question remains, what happens when even the most advanced energy sources are compromised? How does a space station adapt when the unexpected strikes? Imagine stepping into a space station where the air feels crisp, the temperature is just right, and the humidity is perfectly balanced. It's not magic, it's artificial intelligence at work. One of the most critical tasks for any space station is maintaining a livable environment, and AI could play a pivotal role in making that happen. But how exactly does AI manage something as complex as environmental control in the unforgiving vacuum of space? First, let's talk about the basics: temperature and humidity. In space, there's no natural atmosphere to regulate these factors, so the station relies entirely on its internal systems. AI-driven climate control systems could constantly monitor and adjust the temperature, ensuring it stays within a comfortable range for the crew. These systems would use sensors to detect even the slightest changes, responding in real time to keep conditions stable. And it's not just about comfort. Extreme temperatures could damage equipment or even threaten lives. But it doesn't stop there. Air quality is another major concern. On Earth, plants and natural processes help replenish oxygen and filter out carbon dioxide. In space, AI could oversee bioregenerative life support systems which mimic Earth's natural cycles. Picture this: AI managing a closed-loop system where plants grow under carefully controlled conditions, producing oxygen while absorbing carbon dioxide. It's like having a tiny, self-sustaining ecosystem on board, all orchestrated by algorithms designed to optimize every variable. Of course, creating a self-sustaining habitat in space isn't without its challenges. Space is an environment of extremes: intense radiation, microgravity, and limited resources. AI would need to adapt to these conditions, constantly learning and improving to keep the system running smoothly. For example, if a component of the life support system fails, AI could reroute resources or activate backup systems, ensuring the crew remains safe. The real question is, how can AI ensure the station remains habitable over the long term? Beyond just maintaining balance, AI could predict potential issues before they arise, using predictive analytics to spot trends in data. It could also integrate with other systems like water recycling and waste management to create a truly self-sustaining environment. The goal isn't just survival, it's thriving, even in the harshest conditions. So, as we look to the future of space exploration, AI's role in environmental control isn't just about keeping the lights on. It's about creating a home among the stars, a place where humanity can not only survive but flourish. And with every advancement in AI and bioregenerative technology, that vision becomes a little more real. As we marvel at the potential of AI to revolutionize space exploration, there's one critical question that can't be ignored. How do we protect the space station from threats, both from outside and within? After all, a fully autonomous space station isn't just a marvel of engineering, it's also a potential target. Cybersecurity risks, sabotage, and even human error could jeopardize its mission. This is where AI steps in as both a shield and a sentinel, constantly monitoring and defending against dangers in real time. Imagine a scenario where hackers attempt to breach the station's systems. Unlike traditional security measures, which might rely on pre-programmed responses, an AI could adapt on the fly. It could analyze patterns, detect anomalies, and neutralize threats before they escalate. For example, if an unauthorized signal tries to infiltrate the station's communication network, the AI could instantly identify it, isolate the breach, and reroute data flows to maintain operations seamlessly. But it's not just external threats that pose a risk. Internal vulnerabilities, like a malfunctioning module or even a rogue crew member, could destabilize the station. Here, AI's ability to process vast amounts of data in milliseconds becomes invaluable, allowing it to predict and prevent potential disasters before they unfold. Of course, no system is foolproof, and that raises an intriguing question. What happens if the AI itself becomes the threat? Could a malfunction or a malicious update turn the station's protector into its greatest danger? It's a chilling thought, but one that underscores the importance of building fail-safes and ethical safeguards into the AI's design. After all, the future of space exploration depends not just on what AI can do, but on how we ensure it remains a force for good. But how do we ensure that an autonomous space station not only survives but thrives over decades or even centuries? The answer lies in AI's ability to manage long-term sustainability. Think about it. In the harsh environment of space, every resource is precious. From the air we breathe to the materials used to build the station, nothing can go to waste. AI systems could monitor and optimize resource usage in real time, ensuring that every drop of water, every ounce of oxygen, and every scrap of metal is recycled and reused efficiently. One of the most critical challenges is waste management. Unlike on Earth, where waste can be buried or processed in large facilities, space stations have limited capacity. AI could oversee advanced recycling systems, breaking down waste into its base components and reintegrating them into the station's infrastructure. Picture this: a broken piece of equipment isn't discarded. It's disassembled by robotic arms, its materials catalogued, and then repurposed to build new components or even repair other systems. This closed-loop system minimizes waste and maximizes resource efficiency, creating a self-sustaining ecosystem in orbit. But sustainability isn't just about managing resources, it's also about adaptability. Space is unpredictable and conditions can change rapidly. AI could continuously monitor the station's environment, adjusting systems to maintain stability in the face of solar radiation, micrometeoroid impacts, or equipment failures. For example, if a critical system begins to degrade, AI could predict the issue before it becomes a crisis, rerouting power or initiating repairs autonomously. This proactive approach ensures the station remains operational, even in the face of unforeseen challenges. Looking further ahead, AI could also play a pivotal role in planning for the station's future. As technology evolves, so too must the space station. AI could analyze emerging technologies, identifying opportunities for upgrades or expansions. Imagine a station that grows over time, adding new modules or capabilities as needed, all guided by AI's long-term vision. This adaptability ensures the station remains relevant and functional, no matter how far into the future we look. So, how do we future-proof such a complex system? The key lies in designing AI that can learn, adapt, and innovate. By embedding flexibility into its core programming, we can create a station that not only survives but evolves, ready to face whatever challenges the cosmos throws its way. Imagine a world where the stars are no longer distant, untouchable symbols of mystery, but instead become a shared canvas for humanity's creativity. An AI-driven space station could do more than just advance science. It could redefine how we see ourselves and our place in the cosmos. For centuries, space has been a source of inspiration for art, literature, and philosophy, from the poetic musings of Carl Sagan to the visionary paintings of Chesley Bonestell. But with AI at the helm of a fully autonomous space station, this inspiration could take on a whole new dimension. Think about it, an AI system managing a space station isn't just a technological marvel, it's a cultural catalyst. Artists might draw on the station's data streams to create immersive experiences, blending the cold precision of algorithms with the warmth of human emotion. Writers could explore the ethical dilemmas of AI autonomy in space, sparking debates about what it means to coexist with machines in the vastness of the universe. And philosophers, they might find themselves grappling with questions that challenge the very essence of human identity. Are we still the pioneers of exploration if the machines we've built are doing the exploring for us? But the impact goes even deeper. An AI-driven space station could become a symbol of unity, transcending borders and bringing people together. Picture this: nations collaborating not just for technological advancement, but to create something that embodies the best of humanity's collective spirit. The station could serve as a reminder that, despite our differences, we're all passengers on the same pale blue dot. AI in this context becomes more than a tool, it's a bridge, fostering international cooperation and shared purpose. And then there's the question of identity. As AI takes on tasks once reserved for human astronauts, what does that mean for our sense of self? Are we still explorers if the machines are doing the legwork? Or does this shift invite us to redefine what exploration even means? Perhaps it's not about planting a flag or taking a step. It's about the ideas we generate, the connections we forge, and the stories we tell. In a world where AI handles the logistics, humanity might find itself free to focus on what it does best: dreaming, creating, and imagining the infinite possibilities of the universe. So, as we stand on the brink of this new era, one thing is clear: an AI-driven space station isn't just a technological achievement, it's a cultural milestone. It's a chance to reimagine our relationship with space, with each other, and with the very essence of what it means to be human. And in that reimagining, we might just discover something extraordinary about ourselves. Imagine a space station orbiting a distant planet, equipped with advanced AI systems tirelessly scanning the cosmos for signs of life. These systems wouldn't just collect data, they'd analyze it in real time, searching for patterns or anomalies that might hint at something extraordinary. This is where an autonomous space station could revolutionize the search for extraterrestrial life. With AI at the helm, the process becomes faster, more precise, and far more capable of handling the vast amounts of information gathered by telescopes, probes, and other instruments. One of the most exciting possibilities is how AI could process data from telescopes like the James Webb or future deep space observatories. These instruments capture an overwhelming amount of information, from faint light signatures to chemical compositions in faraway atmospheres. AI algorithms trained to identify potential biosignatures such as unusual concentrations of oxygen or methane could sift through this data with incredible efficiency. What might take human scientists years to analyze could be done in a fraction of the time, accelerating the search for life beyond Earth. But it's not just about data analysis. An autonomous space station could also conduct astrobiology experiments in environments we've never fully explored. Picture this: AI-controlled rovers collecting samples from the icy moons of Jupiter or Saturn, analyzing them on site for signs of microbial life. These experiments could be conducted in real time, with AI making decisions about where to dig, what to test, and how to interpret the results. This level of autonomy would allow us to explore and understand alien ecosystems in ways that were previously unimaginable. And then there's the tantalizing question: what if AI were the first to make contact with extraterrestrial life? Imagine a scenario where an autonomous space station detects a signal or observes a phenomenon that suggests intelligent life. The AI could analyze the signal, determine its origin, and even attempt to decode it, all before humans had a chance to intervene. This raises profound questions about how we define discovery and what it would mean for humanity if our machines were the first to bridge the gap between worlds. So, what would it mean if AI discovered life beyond Earth? It would be a monumental moment in history, reshaping not only our understanding of the universe, but also our relationship with the technology we've created. An autonomous space station guided by AI could be the key to unlocking one of humanity's greatest mysteries, and in doing so, it might just redefine what it means to explore. As we stand on the precipice of a new era in space exploration, the role of artificial intelligence is no longer just a supporting act, it's becoming the protagonist. The advancements we've seen so far are merely the opening chapters of a story that could redefine humanity's relationship with the cosmos. So, what's next for AI in space? The answer lies in the convergence of cutting-edge technologies that are pushing the boundaries of what's possible. Quantum computing, for instance, is poised to revolutionize how we process information in space. Unlike traditional computers which rely on binary code, quantum systems use qubits that can exist in multiple states simultaneously. This means they can solve complex problems, like optimizing spacecraft trajectories or analyzing vast amounts of astronomical data, at speeds that would make even today's supercomputers look sluggish. Imagine a future where AI-powered quantum systems can simulate entire star systems or predict cosmic events with pinpoint accuracy. That's not science fiction, it's the direction we're heading. Then there's the evolution of neural networks, which are becoming increasingly sophisticated. These AI systems are designed to mimic the human brain, learning and adapting as they process new information. In space, this could translate to autonomous spacecraft that can make real-time decisions without human intervention. Picture a rover on Mars that doesn't just follow pre-programmed instructions, but can analyze its environment, identify obstacles, and even choose its own path to explore uncharted territory. The potential for discovery is staggering, and let's not forget advanced robotics, which are becoming more agile, durable, and precise. Robots equipped with AI could take on tasks that are too dangerous or tedious for humans, from repairing satellites in orbit to constructing habitats on the moon. With machine learning algorithms, these robots could improve their performance over time, becoming more efficient with each mission. It's a vision of space exploration where humans and machines work together seamlessly, each amplifying the other's strength. But here's the big question: how close are we to making this vision a reality? The truth is, we're closer than you might think. While challenges remain, like ensuring the reliability of AI systems in the harsh conditions of space, the progress we've made in recent years is nothing short of extraordinary. Every breakthrough brings us one step closer to a future where AI doesn't just assist humanity in exploring the stars but leads the way, unlocking possibilities we've yet to imagine. The journey ahead is as vast as the universe itself, and AI is the key to navigating it. So, as we look to the stars, one thing is clear: the future of space exploration is not just about reaching new worlds, it's about redefining what's possible with the help of intelligent machines. And that future is closer than ever. As we wrap up this exploration, it's clear that the concept of AI building the first fully autonomous space station isn't just science fiction. It's a vision firmly rooted in the advancements we're making today. From designing intricate systems to managing day-to-day operations in the harsh environment of space, artificial intelligence could tackle tasks that have historically been too complex or risky for humans alone. But with this incredible potential comes a series of questions that we can't ignore. How do we ensure these systems operate ethically and responsibly in the vastness of space? Who oversees the decisions made by autonomous machines millions of miles away? These are the challenges we'll need to navigate as we move forward. Yet, despite these hurdles, the possibilities are staggering. Imagine a future where AI-driven stations serve as hubs for scientific discovery, resource harvesting, or even as stepping stones for deeper space exploration. The synergy between AI and space technology could unlock doors we've only dreamed of opening. But the journey ahead isn't just about technological breakthroughs, it's about collaboration, foresight, and a shared vision for what humanity can achieve. So, what's your take on all of this? Do you see AI as the key to building the first fully autonomous space station? Or do you think there are obstacles too great to overcome? Let's keep the conversation going in the comments below. And if you're excited about the future of technology and space, hit that subscribe button to join us for more deep dives into the innovations shaping tomorrow. The stars are no longer out of reach thanks to AI. They might just be the next frontier.